Hello everyone. In this video, I am going to discuss about non-exact differential equations which are reducible to exact form. In my earlier video, we discussed about exact differential equations and non-exact differential equations which are reducible to exact when non-exact differential equation of the form homogeneous type. The other one is of the form y into some function of xy dx plus x into some other function of xy dy equals to 0. Now I am going to discuss about other two forms. Let us start that one. Non-exact differential equations which are reducible to exact. In my earlier video we discussed the two forms, two methods to find integrating factor. Now I am going to discuss other two methods to find integrating factors. The one of the methods is, if let us say 1 by n dou m by dou y minus dou n by dou x, if this is function of x, then integrating factor of m dx plus n dy equal to 0 is given by e power integral f of x dx. This gives integrating factor in this case. The other one is, if 1 by m times dou n by dou x minus dou m by dou y, if this is, let us say, some other function of y, then integrating factor of m dx plus n dy equals to 0 is given by e power integral g of y dy. In this case, integrating factor is given by e power integral f of x dx. In this case, integrating factor is given by e power integral g of y dy. Now I am going to discuss one of the examples based on this method. Okay, let us discuss one of the problems based on this method. Solve x cube plus xy power 4 dx plus 2y cube dy equals 0. Now this is a differential equation of first order and first degree, and clearly it is of the form m dx plus n dy equals 0. Now let us discuss how to solve this differential equation. First of all, write down what is the given differential equation. Let us write what is the given differential equation. This is given dE. Given dE is x cube plus xy power 4 dx plus 2y cube dy equals to, let us say, this is 1. Now clearly this is of the form m dx plus n dy equals to 0. Now here m equals to x cube plus xy power 4, n equals to 2y cube. Okay, first identify what is m and what is n. Now we check whether this dE is exact or not. If it is exact, we use method to find solution of exact dE. First identify what is m and what is n. Now we'll check the condition for exactness. If this differential equation is exact, then we can solve this differential equation using that method. If it is not an exact differential equation, we will try to find one of the integrating factors using one of the methods. Then using that integrating factor, we can find solution of this differential equation. Now let us check whether this dE is exact or not. Now what is the condition? Dou m by dou y. Dou by dou y of m. Here m is x cube plus xy power 4. Now differentiate this one with respect to y, keeping x as constant. So simply x derivative is 0. Here we treat x as constant and y power 4 derivative is 4 into y cube. So we get a 4x y cube. Now let's differentiate n with respect to x. Dou n by dou x. Dou by dou x of n. Here n is nothing but 2y cube. And there is no x at all, so its derivative is simply 0. Now clearly these two are not same, so this differential equation is not an exact dE. Dou m by dou y not equals to dou n by dou x. Therefore this dE not an exact dE. This dE is not an exact dE. Now let us use this method to find integrating factor. Then we'll reduce given dE to exact dE. The method is like this: 1 by n times dou m by dou y minus dou n by dou x is, if it is function of x, integrating factor is given by e power integral f of x dx. 1 by m times dou n by dou x minus dou m by dou y. If this is function of y, then integrating factor is given by e power integral g of y dy. Now let us find the integrating factor using this method. Now look at here, the differential equation is like this: x cube plus x into y power 4 dx plus 2y cube into dy equals 0. Now here, short simple method, try to remember. Clearly m is having more number of terms than n, so probably we may get a function of x like that. Probably we may get function of x. Why I'm saying here m is having more terms than m. It is a trick only. It may not be true in all the cases. M is having more number of terms than n, so probably we may get function of x. If here let us say n will have, let us say, more number of terms than m, probably we may get function of y. If let us say m and n are both having same number of terms, in that case we need to check one after the other. So in this case m is having more terms than n, so let us check first this one. If it is not function of x, then we go for this method. Let us check the first one: 1 by n times dou m by dou y minus dou n by dou x, 1 by n. So 1 by, here n is 2y cube, dou m by dou y is 4xy cube minus dou n by dou x is 0. So you will get 4xy cube divided by 2y cube. Clearly you will get 2x. Now clearly there is no y at all, it is function of x. Now we are getting this as function of x. Then we go with this method. Now here in this case integrating factor is given by e power integral f of x dx, that is e power integral 2x dx, that is e power x square. Now this is the integrating factor. Now we multiply this integrating factor with this given differential equation, then this dE becomes exact differential equation. Let us try like that. Multiplying 1 with integrating factor, we get integrating factor is e power x square into given dE. The given dE is x cube plus xy power 4 dx plus 2y cube dy equals to 0. X cube plus xy power 4 dx, 2y cube dy, xy power 4 dx. Now let us multiply this with this one: e power x square x cube plus xy power 4 dx plus e power x square 2y cube dy equals to 0. Let us say this is some star. Now blindly we can say this is an exact differential equation. Now let us solve this differential equation. Already we discussed how to find solution of exact dE. General solution of exact dE is given by integral e power x square x cube plus xy power 4 into dx plus integral 2 e power x square y cube dy equals to some arbitrary constant c. Now here we treat y as constant. Here we integrate terms not having x. Okay. Now clearly this term is having x, so we simply omit this one. We will not integrate this one. Now let us integrate this term keeping y as constant. Integral x cube into e power x square dx plus y power 4 is constant x dx equals some arbitrary constant c. Now let us integrate this one. This can be integrated by taking like this. X cube can be written as like this: x into x square e power x square dx y power 4. Integration of x is nothing but x square by 2 equals some c. Now let us take x square equals some t here. We can write 2x dx equals to dt. So x dx can be written as 1 by 2 times dt. Substitute this here. This becomes, in place of x dx we can write 1 by 2 dt. In place of x square we can write t. So we get like this. This term we write as it is. Already we have written integration of x here. Now let us integrate this one using integration by parts formula, or you can use Leibniz rule for integration. Let us use Leibniz rule for integration. reducible integration says that writing first term t as it is, integration of the second term, that is e power t, integration is e power t, writing minus differentiation of t is 1, integration of e power t is e power t. If you do differentiation of 1, it becomes simply 0, so stop here. So integration of this becomes 1 by 2 t into e power t minus e power t plus y power 4 x square by 2 equals some arbitrary constants. Now let us substitute what is t here. Here t equals to x square, e power x square, like this, y power 4 by 2. We can further simplify this. This is the required solution of 1. Now this is the way to find solution of non-exact differential equation.